Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct online seminars, conduct online seminars for exams P, FM, IFM, and LTAM at Illinois State University. You can find them at smarturl.it/BTDT online. And BTDT refers to my philosophy on how you pass actuarial exams. When you take the exam, every time you look at the problem, you should be able to say, been there, done that. You are prepared this much. So whenever you feel like saying, oh, I don't really have to study this, it's a small topic, I'm just going to study all the major things, this is a bad idea. You need to study every single topic on the test. You have to be over-prepared and you have to overstudy. That's the philosophy I believe in. That's the philosophy I want to tell you about. I have written study manuals for exams P, FM, IFM, and LTAM under the brand BTDT, and you can find information about them at these links. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. A hospital receives 1/5 of its flu vaccine shipments from company X and the remainder of its shipments from other companies. Each shipment contains a very large number of vaccine vials. For company X shipments, 10% of the vials are ineffective. For every other company, 2% of the vials are ineffective. The hospital tests 30 randomly selected vials from a shipment and finds that one vial is ineffective. What is the probability that this shipment came from company X? And here is the solution. Let X be the event that shipment came from company X, and F be the event that exactly one of the 30 vaccine vials tested is ineffective. By applying the Bayes theorem, we get that the probability that it came from company X given that it was ineffective. So probability of X given F is equal to probability of F given X times probability of X divided by probability of F given X times probability of X plus probability of F given X complement times probability of X complement. You should of course memorize the Bayes theorem and the formula. Note that the numerator of this fraction on the right hand side has the conditional probability flipped from X given F to F given X multiplied by probability of X, and the bottom has the same probability of F conditional on the event, but for all pieces of the partition that we split the entire probability distribution into, in this case X and X complement, so vials coming from company X or from other companies. Now we use the data given in the problem. We have probability of X is 1/5, and therefore our probability of X complement is 4/5. Probability of F given X, well, that's 30 choose 1, which is the number of ways to pick one vial out of 30, times 0.10, one ineffective vial from company X, times 0.90 to the 29th, which is the probability of 29 effective vials from company X. And that comes out to be about 0.141. And probability of F given X complement is 30 choose 1. times 0.02. This is the probability of having an ineffective vial from another company, times 0.98 to the 29th, that's approximately 0.334. Now we substitute these values into the Bayes formula, and we get probability of x given f is 0.141 times 1/5 over the same expression, 0.141 times 1/5, plus 0.334 times 4/5. And that comes out to be about 0.096, which is answer A. Please remember this is copyrighted material, and the problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.